All right, hey everybody, Mr. Fortin here. Trig day 4, more on using tangents and whatever else we call this lesson. So this is Wednesday's lesson. Not gonna be due till Friday, right? I'm trying to just get done with what we need to get done before we can go to spring break, but you're not done with spring break yet. Okay, so I said I'd film a video maybe going through the second half of this. I'm just kind of starting on slide 11 in case you're someone who wants to go through problems with somebody else. So hey, that's what I'm here for right now. It's kind of hard to work with people in this strange distance learning era. Another reason why I'm doing this one here is because I want to play with these new tools I see here. I don't know if you can see this in the video, but I got some new tools now in my recording device. So I can do all kinds of good things. Like I can say, hey, I want to solve some equations with ratios. Look at that. That's neat. Okay, cool. So yeah, we'll do that. And now we're really just use our pen here and whatnot. Look at this pen. This is sweet. Okay, check it out here. Your friend hates fractions. And he keeps, we're doing 4A. It's the first one we're doing, solving equations with ratios. Your friend hates fractions and he keeps getting confused when he tries to solve problems with ratios in fraction form. You're going to help him on the screen. In the next 3 screens, review your friend's work. If he started correctly, show how to finish solving the equation. If he made a mistake, find and explain the error, and then fix and solve the equation. You can use show your work on the sketch and in the text box here. So I don't need the pen here. I'm just like really into this whole thing. I just need the mouse. Yeah, I want the mouse. There we go. I do special. Look at that. I can do fireworks. Yeah. Oh, this is sweet. I love this. Okay, so maybe I'll do the focus mouse. You follow what I'm focusing on. Okay, all right. You can do this. Having way too much fun with this. Okay, so this is what we're going to do is we're going to look at this here. It looks like they set up an equation. This is tangent to something. I don't know. It's tangent of an acute angle that's less than 45 degrees because it's probably like the tangent of like maybe 15 degrees or so. So maybe that's it, a 15-degree reference angle, and we added the opposite side, opposite over adjacent x to 5. So let's see if they did this thing right, and I think they did, right? So they did this one correct because they simply want to undo the dividing of the 5. They multiply both sides by 5, and I agree that's going to be equivalent to this over here. Right side, yeah, okay, so we just need to finish solving the equations. This is pretty easy. There we go. 5 divided by 5 is 1, so we just have 1x left. And then we have, this spotlight's amazing. 5 times 0.27. Why do that in your heads? You have calculators for a reason. Now, actually, let me just show you the calculator in here. Okay, look at this. Follow my mouse. Scientific calculator. There we go. Pop it open. And yeah, I mean, you already know this. You're not watching this video here. I'm going to pop this. Whoa! Why is Mr. Fortin so big? That's a new one. Let's move this around here. So we can do 5 times by 0.27. And that's going to tell us about 1.35. Okay? And that sort of solves it there. Right? Yeah. You know what? Just solving a problem like this, ratios here. So what I guess is that this is roughly a 15-degree angle. Okay, because tangent of 15 degrees, I think, is around 0.27 or so. And yeah, my answer kind of makes sense. 1.3525 looks about right. Okay, so anyways, they made no mistakes. Okay, you don't have to show work over there if you showed work over here. You're good to go. Okay, let's go to this, slide 12. Let's turn out this spotlight because we got to read here. So just regular mouse. Or pen. What? No, I want regular mouse. There we go. All right, we're good. All right, so check this out. Review your friend's work. If you started correctly, show how to finish through solving the equation. If you made a mistake, we need to explain. Okay, so perhaps we're typing in here because your friend didn't make any mistakes in the last slide. Okay, here we got a pretty big tangent is my guess. This tangent's probably around for like 85 degrees or so. I don't know. I'm looking at 271 in my textbook. Maybe like tangent 3.9 or so. So yeah, it looks like it's about a 70, actually more like a 75.5 degree measurement. The tangent would be this, but more of the story is your opposite side's way larger than your adjacent side. And that's what's going to make this. It's going to be basically 40% down here. I mean, the answer is actually really easy on this one here, actually. So anyways, let's see how they're solving this one. They multiply both sides by 10. No, don't do that because 10 times by 10 would be 100, and then you'd have 100 over y, and that's going to make no sense. No sense. So, so what I would say here is multiplying a 10 by 10 won't cancel out the 10 on the right side. Okay, so remember we want to divide by 10. Yeah, you can divide by 10. That's one way to do it. There are plenty of ways you can do this here. If you had divided by 10 here instead, 10 divided by 10 would be 1, and you'd have 1 over y, okay? And if I divided this side by 10, I would have 3.962 over 10. And I think most of you guys would solve this problem, okay? Because what you could just do in this situation is you could invert both fractions, right? You could have this be y equals 10 over 3.962 and then get your answer. Okay, so I'm going to do that. I'm going to move Mr. Fortin here. Come on. Come on. Buggy. Buggy. And we're going to get our answers here. So 10 divided by 3.162. My sister-in-law, who now lives in San Francisco, built this. That's why I'm using it. I'm going to tell her about these bugs too. So anyways, yeah, the camera gets all wacky. So I'm going to like, this is the beauty of living in San Francisco. All these tools we're making, you know everybody who makes them. You're connected. Anyways, this would be about 3.16. This is going to be your answer. And that kind of makes sense here. So let's see, about 3.16. Whoa, 3.9. Wait, hold on. I messed this up. 3.962. So answer should be about 2.52 on this one. Should be y. Okay, so anyways, let me undo all that because I think I would do it differently. Okay, so I would maybe do it differently. So here, like on this problem, if I were doing this and I'm trying to correct what they're doing, I would cross all this out. Okay, and what I would do, to be honest here, is I'd either multiply both sides by y, okay, because y divided by y is 1, and then you got the y over here, right? And then you have 3.962 y's on this side. And then you just divide both sides by 3.962. That's the way that I would probably recommend doing it here. But if you want something really advanced, right, because that's the way I think most of you guys would do it here. If you want something really advanced, I would do an extreme swap, okay? In this situation, I would do an extreme swap. Here's what an extreme swap is. Remember, we can do mean swaps. You can also allow to do extreme swaps, right? That's totally illegal move here. So here, I would maybe think about this. The easiest way for me to do it is to think about this as a proportion. 3.962. Well, that's a tangent because your opposite side is 3.962 times larger than your adjacent side, 3.962 to 1. So here, opposite side, 3.962 larger than your adjacent side, 1, right? The y here, okay? But anyways, you got to figure out what y is here to make this in a 3.962 to 1 ratio, not a 10 to whatever ratio here. So here, I would swap the extremes. Remember, you can swap the means. That's sort of the formally written thing in the textbook. But remember, if I just rewritten it like this, okay, if I moved this whole thing over here, 3.962 over 1, look, what was originally my extremes, right, 3.962 and y, are now my means of the proportion, okay, the proportions. Check it out here. I can mean swap here, right? This is what justifies an extreme swap. We know we can mean swap. We've justified that already. But extreme swap is the same exact thing as a mean swap. It's just your proportions written. This is on the left side. If it's on the right side, the extremes become means. So anyways, you're allowed to extreme swap. That's how I would solve this one. Let me X this out. You don't need this at all. So here, what I do this here is that y is the denominator. I can actually move it over here. Y would be equal to 10 over 3.962. And there we go. And I've already done that in my calculator here because I did it previously. So y has to equal 2.52, okay? So for you really advanced folks who want to go faster on this, just swap your extremes. Divide and you got your answer, okay? Want to go a little bit more slowly? You got y in the denominator, then multiply y to both sides to cancel out the y denominator. If you're dividing by y, multiplying by y undoes that, right? It's the exact opposite of what divide by y means. Dividing by 5, if I multiplied by 5, I would just get back to where I was, okay? So that's how you can solve in this situation. Okay, there's slide 12. Let's keep on going. Hey, you watched this video because you want to do some problems with some people. You're doing it with good old Mr. Fortin right now. Review your friend's work. If you started correctly, show how to finish the problem here. Well, I'm guessing you made a mistake. We got to analyze this one here. What did he do? Okay, it looks like he has a pretty big tangent here. That's a tangent of 5. Again, well, we just dealt with this. Tangent of 5 is around 78.5 degrees here. So that's a pretty big angle. So this has got to be 100. You can just really easy tell the answer to this is 100. Because 100 divided by 20 is 5. Ooh. Nice. But what do they do to solve it, right? What would be the steps here? Multiply both sides by 20? Yes, they did it right. Let's just finish solving this one here, okay? Because what undoes this, because we want to isolate B, right? Our goal here is we want to isolate, right? Isolate means get by itself, okay? We eventually want to get to B equaling something, right? And once we get B by itself, next to the equal sign, we've done our job. We've gotten to the right place to solve for the variable, to figure out what the variable must represent, the essence of that variable, okay? So if B is being divided by 20, and that's what arrives us at 5, well, if we multiply both sides by 20, that undoes the division of 20. And then we get B. Oh, wait, they missed this. That's what they missed. They didn't multiply both sides by 20. You didn't multiply, in all caps. I don't yell at people. You didn't multiply both sides by 20, okay? If you're going to multiply the left side by 20 to cancel out that dividing by 20, you got to multiply the right side by 20 to make sure your equation remains balanced. Remember, an equation means things are equal to each other. It's just like a scale, like a weighed down scale. They equal each other. I multiply one side by 5, make it way heavier. My scale gets all balanced. They're not equal anymore. I got to multiply my other side by 5 so that they're actually in the same place here, okay? So that's what they did wrong, okay? So the right idea, this is being divided by 20. Let's multiply by 20. But you need to use the multiplication property of equality. Multiply one side by 20, multiply the other side by 20. Equation's balanced. I know that I found my answer. And there we go. Good to go there. All right, let's keep on jamming. Let's keep into it. Math, baby, math. It ain't too bad. I'm just doing here with good old Mr. Fortin. Let's get it done now. All right, they multiply both sides by x. Sure. Why not? There's a faster way, but I agree. If I multiply by x here, that's going to cancel out x out. What keeps my equation balanced? I multiply one side by x. I need to multiply the other side by x, so my equations remain. It's the statement of equality that we're given at the beginning remains true, okay? So they cancel out. 10 equals 2.1x. I got to go to my trusty calculator right here and figure that out, right? Divide by 2.1, and I got 4.76, okay? So 4.76 roughly equal to x, okay? And we're good to go there. All right, let's keep going. You know, I think I was pretty generous giving you guys till Friday to get this thing done. You know, if you really sat down to do this, I don't think it takes super long, but let's do it here, okay? Just completed 4 solutions, and you identified some common errors, right? So the whole reason why this exists, this assignment, is because we know people make mistakes. People need some practice on some things. In fractions, right? Come in 9th grade, 10th grade, like, fractions. Oh, no. Not too bad. Let's just keep an eye on things. Keep practicing. Keep pushing forward. You can get there, okay? So you got to reflect on this process because it'll help identify important questions and noticing. You want to notice and deepen your understanding. That's what you want to do. What questions do you have? You may want to note any steps of the solutions you're still unsure of. Think about that. It's kind of hard for me to come up with that on my own because, you know, I've been doing this a while. But what do you notice that might help you and your classmates be aware of common errors in solutions? Okay, do one thing, right? Did I do something just to one side, or did I do the same thing to both sides of an equal sign? That might be something you write down there. Sure, why not? All right, number 16 here. Wait, we're back to trig. We actually see the right triangles here. 57 is our reference angle. So use the tangent button to solve for the missing. This is just practice, just tangent practice. This is it here. Use the tangent button to solve for the missing side length. Remember, the tangent button tells you the opposite of our adjacent ratio of the angle measure you enter. Yeah, learn this is old. This is old hat by now, right? We did this on Monday. Not a new hat. We've been wearing this hat a while. This is an old hat here. So, anyways, I was just like do it out. Right, in case you really want to see more examples here. That's why you showed up today. Okay, tangent of 57 degrees. Well, this tangent has the unique ratio of whatever that is divided by 5 is going to have to match whatever the unique ratio is that goes with tangent 57. Here's my opposite side. Here's my adjacent side. Okay, so now what do we do to both sides? Well, the last slides showed us very clearly. Simply got to do this. Multiply this by 5. Multiply this by 5, okay? 5 times by the tangent 57 is going to get us there to whatever C has to be, okay? So I get this. Got to move myself out of the way again. God, Mr. Fortin, why do you keep putting yourself there? Okay, so I'm going to do 5 times by, and I can even just do this like here. Do it together in the calculator. It's 57. Boom, here's my answer. Good to go. And does my answer make sense? You always want to ask yourself, does your answer make sense? And you can go to just the 10th place. That's what your book did, so that's fine here too. 7.7, and I think it does. 57 degrees is on the larger side of acute angles. It's on the outside of 45, where the opposite side should be larger than the adjacent side, because 57 degrees is larger than the measure of the degree that would be here. So it'd be a 23-degree angle. So this has got to be shorter than that, right? Because this is a larger angle of the two acute angles. So anyways, my answer makes sense. I feel pretty confident about that. I don't think I made any mistakes. Keep going on here. Solve for the missing side length. Use the tangent button to solve for the missing side length. Remember, tangent button tells you opposite over adjacent. This is easy. What are we talking about here? Tangent of 83 degrees equals n over 11. Okay, so that's simply 11 times by tangent 83. Man, it gets boring if it gets too easy, right? This is boring. I think this is a little boring. So let's do it here. 11 times by tangent of 83. We're in degree mode, good to go. 89, okay? So n equals 89. So n is, right, our opposite side's way larger than our adjacent side because that angle's approaching 90, right? We're getting towards the largest acute angle we could have, which would be 89.9 repeating. Okay, so we end up with 89.5, 0.6. Round up to 0.6 here for the n, and we're good to go. Okay, and it says, remember to write your final answer here. Hopefully you read it over there too. All right, slide 18. This one here. Okay, so you have two options on this one here. Here's how I would do it. I would just because I like having my numerator be a fraction, I would find this one here is going to measure 90 minus 52. Remember, the acute angles of a right triangle are complementary. That was a corollary. Or was it a theorem? I don't know, in chapter 2. The acute angles of a right triangle are complementary. 90 minus 52 is 38 degrees. So my recommendation to you is if our unknown is right here, that's our adjacent side for the 52-degree reference angle, but it's the opposite side of the 38-degree angle. So I would use the tangent of 38 in this one. Just a little bit easier. That's it. Just a little bit easier, a little bit faster. I see fewer mistakes that way because here, if this is our reference angle, then the opposite of the reference angle is y, adjacent to it is 23. It's vice versa if it's the 52. You'd have to do, for the tangent of 52 degrees is 23 over y rather than y over 23. So remember, the tangents of complementary angles are the reciprocals of one another. This is y over 23 for the 38-degree angle. Its complements, tangent, would be 23 over y, okay? But I like this because what do I have to do both sides? Pretty easy. I just have to multiply by 23. Pop open my scientific calculator. I finally found the right place for me to be in this video. And we got 23 times by tan 38 and 17.9. Does that make sense? Well, yeah, it's just a bit smaller than the 23 there. I could buy that. This looks about 18. It's not that much smaller than here. So you know what? Fireworks. We got another one done. We got another one done. We got another one done. You're going to hate these things here. You're going to hate these little celebrations. What about, I want to get out of here. Save mouse. I want to rock on. This is just cool. That's just cool. Heck yeah. Yes, this is awesome. Okay. Thank you, Miss Henny. You can refer to her as Miss Henny. My sister-in-law made this. Pretty neat. Okay. Anyways, how do I get back to the mouse? Back. Mouse. I have mouse. That's what I want. I want mouse. Okay, cool. You follow me. Follow me. Let's go. Oh, my smiley faces keep going. No, they left. I still have I still have the fireworks going. Oh, that's fun. Okay, use the tangent button to solve the missing side length. Yeah, these aren't too bad, right? Okay. Hey, 23 degrees, I can do that, but what's cooler than 23 degrees is 90 minus 23, right? 90 minus. All right, it's too much with the fireworks. 90 minus 23 is what? 67. So here, I'm going to use tangent of 67 in this problem because I want this to be my opposite side. And I want this to be my adjacent side. My unknown, if that's my opposite side, then it's in the numerator. And that's just easier to solve, right, people? Don't you agree? Hopefully you take away that from this this task, and you're learning a new thing to make you a little bit more confident on stuff like this here. Okay, multiply both sides by 19 is all you got to do now. Tangent is 67 times by 19. Okay, 44.7 is what I got. 0.8, right? We got to round up here. Equal to k. Does my answer make sense? Yes, 67 and 23 are pretty far apart, so this is going to be a lot longer. 44, yeah, this looks a little over twice as long as that. Yeah, I think we're good to go. All right, let's keep going. Woo, we're getting tired. We're going to be able to Friday to do this. We're just going to get it done. All right, same deal. I'm not messing with that egg. I'm messing with its complement, my friend. So we got here 59 degrees. No, mistakes on this, do you? 49 degrees, okay, right? Because 50 plus 30. Wait. I was right about that. We should have been 59 because 30, 60, right? So we're just one above 30, one below 60. There we go. Okay, tangent of 59 degrees equals, wait, why did I do that? I don't want to do that because I had it originally where my opposite is of the 31 degree angle would put the unknown in the numerator. So tangent of 31 degrees equals z over 27. You know what to do. Multiply both sides by 27. Whoa, I got all crazy there. Let's see what we got here. 27 times by tan 31. And I got 16.2 z equals about 16.2. Yeah, I try to do that about symbol. I'm not like super aggressive in requiring that, but yeah, these are approximations, right? Tangent of 31 degrees, that's not one of those special angles where we know the exact tangent. We just know an approximation. Okay, there we go. We done, and we found 5. Come on. Okay, 5 degrees here. That makes it easy. This is 85 degrees there, and that's not what I want. I want the 5 degrees because I know the opposite. Wait, hold on. This is a hypotenuse. Hold on. This requires more work. 5F, I might make a separate video on this. Watch out for 5F because here's what you have to do on this one. I might have to send this one out. Okay? Our opposite here, right? This is our opposite side. I guarantee you won't notice this unless I point it out to you. It's only because I've been trained fluently on this trig stuff. This is our opposite side. There's our adjacent side. So you know what? Let's let the adjacent side be x. We don't know what our adjacent side is. We don't know what our hypotenuse is. It actually is asking us for what our hypotenuse is. So this one's a little tricky. They don't even really give you any warning about this here. So what do you have to do in this one? I'm hoping I get some questions on this, in which case I can just send this video. Is that you have to, on this one here, you got to ask yourself, well, what are the tools I have right now? Well, I only have the tangent right now. So if I have tangent of 5 degrees, okay, I could set up this equation, 9 to x, and you got to ask yourself, well, I'm not being asked what x is. I'm not being asked what that adjacent length is. But then you can ask yourself, well, what if I did know that? Like if I gather some more intelligence about this problem and I understand more like inputs of what is there, right? I know this is a 5 degree angle. That's an 85 degree angle. And I could figure out that side, right? I could. If you did know this side, is there a way you could then figure out that side? Think about it for a second. Well, you have a right triangle too. That's another thing I didn't mention. There's a right triangle problem. You have the opposite leg there. You can figure out what the adjacent leg is there. Well, if you have this leg and this leg, if you have both legs of a triangle, can you figure out what the hypotenuse? What do we know about the sums of the squares of each leg? It's equal to the square of the hypotenuse. So we can use the Pythagorean theorem after we know what this adjacent side length is to figure out what that hypotenuse is. So very, very tricky, this problem. They had to just drop this in there to make this a little bit harder. And we're going to think ahead, right? When we get back from spring break, we're talk some new ratios that are going to allow us to solve for m directly. But we don't need to overwhelm you with that. We're going to use some skills you have right now, which is using tangent and then using the Pythagorean theorem to figure out what the hypotenuse is. Tangent to get the missing leg, right? We'll use tangents only for getting missing legs. And then Pythagorean theorem allows you to get the hypotenuse, right? That's what we're doing for now. Okay, tangent of 5 degrees equals this. I'm going to do my mean swap. I explained that earlier in the video. This is totally a legal move, okay? And so now I just need to do 9 divided by tangent of 5 degrees. And there we go, 102.9. So x equals 102.9. So now I want to solve for m. Okay, m here. So I might do this on here. I might put an equation so you can see it separately now. I know that this here, okay, is because I solved for it using trigonometry, right? I knew it was a right triangle. I knew a reference angle. I knew I had one of the legs. I can get the other leg using the tangent function. 102.9, tangent ratio that is. Yeah, 102.9 is here. So now I have both legs. What do I know about both legs? How's that going to help me get the hypotenuse? Well, I know the sum of the squares, okay, 9 squared plus 102.9 squared would equal m squared. Oh, lowercase. It was lowercase in the diagram. Why is it doing uppercase there? There we go, m squared. There you go. There you have it, okay? So we can use Pythagorean theorem to help get us there, okay? So 9 squared, we can do that in our heads, right? That's 81. 102.9 squared, I don't think so. I don't think you can do that in your head, or else you're in the wrong class. But anyways, plus 102. All right, so let's get rid of this here. Put a new row here. So it'll be 102.9 squared up is this big old number, okay? And then that's going to be 10588.41 equals m squared. Okay, so now I'm going to combine like terms, right? Combine add these two constants together. So I need to take this that I have here, take that answer, right? That stands for answer. It's what we just got in the top row above it. And I'm going to add 81 to it, okay? And I got 1,000 or 10,669. Oh, interesting. You think that's a perfect square? I don't know. But the 0.41 is kind of unnecessary, right? Like it's just kind of like tacked on there. It's not precise, but anyways, we got that here. So I just need to take the square root of both sides now to figure out what m is. And sure enough, we can use a calculator for that to figure out a decimal approximation, right? It's a messy, it's a funky decimal right now, so let's just take the square root. We'll end up with a funky decimal. We don't have to worry about simplifying any radicals here because we're not even putting in like a whole number here. So we don't have to worry about simplifying radical stuff here. So 10,669.41 equals m squared. You follow me so far? You follow me? What am I do to both sides? I need to take the square root of both sides. So I need to take the square root of this, which I can't. Oh, I can do this here. Just I want to show you. Ah, Mr. Ford's got to move again. Come on, move. Whoa! What's this doing here? Share with big. What is this? Summary of big type? I don't know. There's a bug here. Find another bug. What is going on down here? What the heck does that mean? Anyways, let's do this. There we go. No, I didn't want that. I wanted this. I wanted the square root symbol. Is that going to put it over? Nope, it's not. I'm doing too much. Mr. Ford is being pretty extra right now. This, and this, squared. That's what I want to do, okay? Because the square root of m squared, right? That's just the side of m squared, which would be m. Okay, so let's do it, guys. Yeah, teachers do it. They take their time. I'll take my time. All right. So now I take the square root of this number up here, right? 10,669, and I get about 103. Okay, 103. That kind of makes sense. Look, it's a little bit larger, right? This is side length 9. That's not very significant when your other leg is 102.9. So this is just going to be just a tad bigger, right? 5-degree angle there. That's not a very big reference angle. So anyways, my answer here, boom, it's completely necessary, is going to be 103.3 equals m. And there's my answer. And I think we need some fireworks now. Here, and here, and here, right there, right there. There's my answer. I love it. I love you. I love these new tools. I love this. I'll even put smiley face down. We're keeping it 100. We got this with some math, and we're going to celebrate too. Wow, this is a great way to end this video. I'm breaking this video apart. This will be a special video for 5F, but I'm keeping it on the main video too, okay? For those of you watching the rest of the main video, let's go on to the next slide. Oh, I got to get that out of the way. I need to choose my mouse. All right, I got my mouse here. And is that it? I think you just have to reflect after that. Oh, summary of big ideas. Imagine a friend. Wait, we're still doing fireworks. We don't want that. Move Mr. Fortin again. Okay, imagine your friend Beyonce missed class today. Write a brief summary of what you learned about today. Use the sketch tool to triangle right to illustrate your summary. Remember to describe what the tangent button does and to describe the relationship of the tangents of complementary angles of the right triangle. Oh, interesting, okay? So that's one thing at least to call out here. If my angle is here, all right, these are complementary angles, right? Acute angles of a right triangle are complementary. This is 90 here. It's got to add up to 180. You got 90 degrees for these two, okay? So, right, here's my opposite side for the y degree. Right, this is opposite for the y degrees, but it's adjacent, the adjacent leg for x degrees, okay? And then same thing here, right? This is opposite for x and adjacent for y, okay? So the tangent of one of two complementary angles is going to be the reciprocal for the second of two complementary angles, right? Is what you can say here. That's what this tells us here, right? You're using the same sides as in your tangent function. They're just in different places, right, for your tangent ratio. Okay, and that's that. All right, any questions? There's the end of class. Hopefully this video was helpful. You just want to sit down and do something with it. Your head might be spinning. Relax a little bit. It's fine. Should you do this before Friday? Message me if you have any questions. Thank you guys for watching. Take care. Bye.